All right, folks, here's the video that's related to your assignment for today, the Hovercraft Analysis. Typically, I do this with my students, but seeing that I can't be in class today, you are going to have to watch a video of me and my kids having the fun. And maybe at some point in your lives, you will be able to have that fun too. So here's the video. I'm just going to play it. It's only 18 seconds long, and then we will dissect it piece by piece and look at the parts that you need to focus on. So here you go. All right, so I know that's a little bit far away, but here's what's going on. I am going to be pushing my 3-year-old who's on the hovercraft. And so the hovercraft, basically all it is a board with a blower motor on it, which is actually from my shop vac. And the blower motor actually blows air through a top hole in the hovercraft, and then the air comes out these holes on the bottom in a way where when the air comes out the bottom, it spreads across the floor underneath the hovercraft and creates a thin layer of air and actually pushes the hovercraft up ever so slightly. So the hovercraft is literally floating on this thin layer of air, and when it does that, it gets rid of all of the friction. At some point, I'll be able to show you that on a real hovercraft because I do have one at school. So here's what's going on. So here's me. I'm going to be the first pusher. Here's my 3-year-old who's on the hovercraft, and here's my 1-year-old. She's just sitting there watching because that's what she does. And then here's my 7-year-old. He's on the other side waiting for my 3-year-old to come across, and he stops him. So he's the second pusher. So we have my 3-year-old who is a rider on the hovercraft. We have me who's the first pusher, and then we have my 7-year-old who is the second pusher. And so I'm going to play it and stop it and explain each part that we have to look at for this assignment. So the first part is my 3-year-old just sitting there on the hovercraft without any air blowing because the blower motor is turned off. Okay, so that's part number one. All right, part number two is my 3-year-old on the hovercraft, but now the blower motor's on, so there's that little thin layer of air pushing up on it, so it's floating ever so slightly. So that's part number two. He's sitting there, but the air is on. All right, next, the third part is me pushing. So that process of me pushing is part number three. So notice how my 3-year-old's motion was as I pushed. My 3-year-old was stopped and now is moving at some sort of velocity. All right, so now I play it, and he's going across nice and smoothly. Just a nice constant motion, nothing slowing him down. So that's part number four. So then moving on, he gets to my 7-year-old, he gets stopped. So my 7-year-old pushes to stop him, basically pushes in the opposite direction that he's moving to stop him. And so then notice that my 3-year-old was moving and then goes to a stop. So that's part number five. And then part number six is my 7-year-old now steps away, and my 3-year-old is just sitting there with the blower motor still on. It should have stayed in there to keep it going for part number six. So the blower motor is still blowing into it in part number six. And then part number seven is my 3-year-old sitting there without the blower motor on. So it's just basically the same as the first part. All right, so those are the 7 parts that we'll need to focus on for the hovercraft analysis assignment. What I'd also like you to focus on for this is for parts 8 and 9, that we don't focus on the hovercraft and rider, who's my 3-year-old there, But we focus on me as the pusher for part number 8, and then we focus on my 7-year-old as the pusher for part number 9. So let's go back to the beginning, and let's go back to that part where I'm pushing. We'll get to that process here shortly. So as I'm pushing, my 3-year-old goes off that way, but I basically stay in place. I know I move a little bit, but basically, let's just accept the fact that I stay in place. So as I'm pushing my 3-year-old forward, I stay in place. I don't go backwards, but I am just basically in one place. So we call that at rest. So then we get to, so that's part number 8. So you're focusing on me as the first pusher. All right, now my 3-year-old got stopped, and while my 3-year-old got stopped, my 7-year-old was sitting in place, pushing the hovercraft that way. Well, what do you think the hovercraft and my 3-year-old were doing? They were pushing him that way, but he did move, so he was also in place. So that is part number 9. All right, so before we get into the actual worksheet assignment that you're going to fill out, I want to go through a few notes about just some general things about forces to get us started. We have several other notes we'll get to later, but this is what I want you to focus on for this class period. So here's my introduction to forces notes, which will be posted later, but for the sake of this video, we're only focusing on the very beginning. So here's the definition of a force. It's an interaction between two objects that results in a push or a pull. So that's any interaction between two objects. Basically, when two objects touch, there is an interaction. And that interaction, it's a two-way street, meaning if one pushes one thing, the other thing pushes right back. And that's always the case, and so there always has to be the interaction between the two objects. So there can't be some sort of interaction of one object. There cannot be a force unless there's another object that's interacting with that one object. And the one thing about forces is it's the cause of motion. So leading up to this, we've described motion with graphs and mathematical relationships and explanations. We've talked about how things were moving. But now forces will tell us why they move the way they do. And that's the new way of thinking, I guess you could say, moving forward for the next couple units. All right, so there's one specific thing here I'd like to focus on. It's what I call a net force. And the net force just means that there is more force in one direction than the other. And you'll see me show that as F and with subscript net. And you'll see that quite a bit. Okay, so there are several conditions of forces. So there's two conditions that are the same, at rest and constant velocity. So when you are at rest or at constant velocity, the condition of the forces is actually the same. So that means you are in equilibrium. That means you have what is called balanced forces. And what I mean by balanced forces is you have the same amount of force in both directions. And in this case, you have a net force which is equal to 0 because you do not have more force in one direction than the other. The F net is the amount of extra force in one direction than the other. All right, so at rest and constant velocity, those two are the same condition for forces. The other condition of forces is accelerating. That means you're either speeding up, slowing down, or changing directions. So what this means for forces is there's no equilibrium. So when you think of equilibrium, think of just kind of staying the same. It's relaxing. You're almost meditating. But when you're not in equilibrium, that means it's chaotic. You're feeling changes, and so it's just not as restful, not as meditative. So when you have no equilibrium, that means you have unbalanced forces. And unbalanced forces means you have more force in one direction than the other. And in fact, you have more force in the direction of the acceleration. So previously I had said that think of acceleration as a force. So if something's slowing down, the acceleration is working against the motion. If something is speeding up, the acceleration is working with the motion. So the F net in this case is not equal to 0. It's something. It is just what is that amount of extra force in one of the directions. So say I have a force of 10 going to the left and I have a force of 6 going to the right. My net force will be 4 going to the left. All right, so that's some general stuff about forces that should get us enough information for what we have to do for this assignment. All right, so I want to show you the assignment, and I actually did show you how to work out the first one and then just get you started on the second one. So here we go. No, here we go. All right, so this is the Hovercraft Analysis assignment. This has actually been a pretty popular assignment. One, because I've allowed people to have fun on Hovercraft, which I know you're not getting at this time, but however, you will get your time with that Hovercraft. I absolutely promise. So what you're doing with this is you are looking at 9 different parts of the hovercraft in the video. And I already stated them in the video. So let's just go through it quickly. You have number 1, the rider hovercraft, which was my 3-year-old. Just sitting on the hovercraft. It's at rest. The air source is not turned on yet. See, there's off on the air source. The second one is the rider hovercraft is still at rest, but the air source has been turned on, and so it's just sitting there on that little bit of air, pushing it up and keeping it off the floor ever so slightly. Then the third part is where I pushed, I'm the first pusher, I pushed the hovercraft rider to the right. And then the fourth part is I'm no longer pushing, and the rider hovercraft is just going across the floor. And then the second pusher, which is my 7-year-old, pushes on the hovercraft rider to the left, so the opposite direction that the rider hovercraft was moving. And then after the rider hovercraft was brought to the left, brought to rest, the second pusher, which is my 7-year-old, stops pushing on the hovercraft. That's when he went away from it. But the air source is still on. And then the last one, my 3-year-old is sitting there on the hovercraft with the air source turned off. That's when I unplugged it. And then 8 and 9 is while I'm pushing the hovercraft, what's going on with me as it relates to forces. And then number 9 is my 7-year-old pushing back to stop the hovercraft. What's going on with him related to forces as that's happening. So let's look at number 1 and let's talk about how I would like to see a force diagram. So there are 3 things that you need to do for this, for each situation. You need to draw physical diagrams. So as you can see, my artist skills are superb. I use stick figures for people. I always will. I have a nice circular disc for the hovercraft. And then I have this nice square for the blower motor. And that is, it says off because it's off. And then I have a line here and a line there to show you that this is the floor. So I hope that's a good enough physical diagram for you, because it has to be, because that's as good as it gets from me. All right, so the force diagram. This is how I want to see force diagrams. I want you to draw a dot in the middle of the square for the force diagram section, and that dot actually represents the hovercraft rider. And so now we can just not worry about all the details of the drawing, and we can just say, all right, this hovercraft rider is just a dot now, and I just want to know what forces are acting on this hovercraft rider as one thing. And so I have to look at everything that's touching the hovercraft rider. And the only thing that's really touching the hovercraft rider is the floor. So it's the floor below the actual hovercraft. And when the floor is below it, the only thing the floor can do is push up on the hovercraft. And so from my dot, I have an up arrow, and I just put an F for force, and I put by floor. So now I know that I have a force going up by the floor. Now there's one thing, or one force that can act on an object that doesn't necessarily have anything touching it, and it's the force due to gravity. And gravity is actually applied by Earth. So Earth is the object that applies the gravity. So Earth can pull things with its gravity, but those things do not have to touch Earth for it to happen. So that's a different type of force than the other forces. All the other forces, you need some sort of contact, but this gravity force, you don't need to have contact. Well, gravity is always going to be pulling down, and so here I have a down arrow, and that down arrow represents my force by gravity. And so I put F by gravity. Now I want you to notice one thing here. I do have arrows that are the same size. I have one going up that's about that big, and I have one going down that is the same size. I need to have the same size arrows because I'm at a condition where I am at rest. So my description of motion is at rest. I'm stopped, I'm just sitting there. That means I'm in equilibrium. That means I have balanced forces. That means I have to have the same amount of force in one direction than the other because they basically cancel each other out. They balance each other. And so that's why I have this up arrow this size and this down arrow that size. So whenever you're in equilibrium, that means you're at rest or you're going a constant velocity, you need to have the same amount of arrow in both directions, whether it's up, down, or right, left. Okay, so in the description of motion, as I stated before, I put at rest. You could say stopped. It doesn't really matter to me at this point. But there's basically only a few descriptions of motion you have to write. You don't have to get detailed. You can say you're either at rest, or you can say you're going a constant velocity, or you can say you're speeding up or slowing down. And that relates to acceleration. All right, so the second picture for number 2, this is where the air source gets turned on. So now I've changed my picture to, instead of saying off, it now says on. So that's pretty descriptive. I hope you can follow with that. But everything else should look the same with the exception I have these little arrows pushing up, and these little arrows represent the air that's pushing up on the hovercraft. I couldn't draw air because it's basically invisible. So those are my little air particles pushing up on the hovercraft. So now you can see that the hovercraft is now not really being pushed up by the floor necessarily. It's actually being pushed up by air. So just think about, if the floor is not actually touching the hovercraft, but now we have this forced air touching the hovercraft on the bottom, what's actually pushing up on the hovercraft? Is it the floor or is it the air? Well, it's not touching the floor. It's touching that forced air. So what do you think? All right, so I'm not going to do the force diagram for you because at this point I think you should be able to do it. And I'm not going to tell you the description of motion because at this point it's written right here. Oh, whoa, I gave you the answer. So anyways, so that's going to be your assignment for today, and then we'll follow it up with another assignment that reinforces these force diagrams, and I'll go further in the notes. So I hope this video was helpful. You can obviously reach out to me through email, or I'll maybe even be able to Zoom, and I can address any questions you may have. So thank you for your time, and enjoy class for the day.